So say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo.
Turn to your calculator reference sheet, which starts on page 135. Copy down the instructions on how to use your calculator to solve a system of equations using graphing. Today we're going to talk about solving systems of equations by graphing. But first we're going to create a foldable to help us learn the different ways that you can solve systems. Take the 2 sheets of paper that you picked up at the beginning of class. Stack them one on top of the other. Then move the top piece of paper down about an inch. Then you're going to fold the bottom up to the top and leave about an inch between the top sheet of paper and what you're folding up. It should create 4 separate flaps. And fold it down. Then staple the very top twice to hold it together. Turn to page 40 in your interactive notebook, section 3.1, Solving Systems of Equations. Please glue the foldable we just created onto your notebook page. You may need to trim the sides a little to get it to fit. Label the very top page Graphing. Label the next one Substitution. Label the next one Elimination. And finally, label the last tab Matrices. On the very front of your foldable, please copy this statement. Section 3.1, Solving Systems of Equations. A system of equations is a set of 2 or more equations that have to have the same variables. Each system can be classified as consistent and inconsistent. A consistent system happens when a system has at least one solution. A consistent system can also be classified as independent or dependent. It's independent when a system has exactly one solution. For example, when lines cross at exactly one spot. That would be an example of a consistent, independent system. A dependent system would be when a system has an infinite number of solutions. This would happen when you graph 2 lines that look like 2 different equations, but once they are graphed, they are right on top of each other, creating an infinite number of intersections. This is called a dependent consistent system. An inconsistent system would be a system that has absolutely no solution. This happens when we have, for example, parallel lines. They never cross and therefore have no intersections or no solutions. We are able to use our calculator to help us graph and find intersections. In order to use our calculator, we need to have y alone. In the first problem, I already have y alone, so I can go ahead and put this directly into my calculator. To do that, I'm going to press y equals. Clear anything that's already in your y1 and type the first equation, 3x minus 4. Then we're going to type the second equation into y2, negative 2x plus 1. Whenever we're graphing a new system of equations, it's always a good idea to start with our standard window. To get there, we're going to press Zoom and select option 6, Z Standard. This will give us a standard window of negative 10 to 10. There's our first equation that we graphed in y1. And our second equation is coming across from y2. We can see that this system has exactly one solution, so we can classify it as consistent and independent. To find exactly where they cross, I'm going to press second, calc, that's the trace button. And I want to find where they intersect, so I'm going to select option 5, intersect. The calculator will then ask us a series of questions. The first question it will ask us is first curve. This is asking us to put our cursor near the intersection on the first line that we graphed. To do that, we need to use the left and right arrow keys. We don't use the up and down arrow key to move along the line. The up and down arrow key will simply move us from y1, our first equation that we graphed, to y2, our second equation that we graphed, but it will not move us any closer to the intersection. When I press the right arrow key, you can see that the cursor moves up towards the intersection. You want to move your cursor as close as you can to the intersection. It does not have to be exact. Once you are close to the intersection, please press enter. Now our calculator is asking us for the second curve. We can see that our cursor is still close to the intersection. So all we need to press is enter 2 more times. The first time we press enter, the calculator will ask you, do you want to guess where the intersection is? And we don't ever want to guess, we want the calculator to tell us. So we're going to press enter the second time. Then the calculator will tell us what our intersection is. Our intersection is at 1, negative 1. We always write our intersection as a point. We now need to copy the graph we see on our calculator onto our paper. To do that, you can of course graph by hand using the slope and the y-intercept. The other option is that we can graph using the table on our calculator. Second, table. If you find that your x values are large or are different from what's found on the x values on our table, Remember, you can change those by going to Second and Table Set and select an x value that's found on your graph, like 0. Then return back to your table. You can see that I have one column with x values, and then I have two columns with y values. This is because we have graphed two separate equations. If you have a color calculator, then your columns will match the color that you had for y equals. This first equation is graphed in blue. So each of these is a set of points lying on that line, 0, -4. One, -1. Then you can draw a line through 2 points. The second equation is graphed in red on my calculator. At x is 0, y is at 1, 0, 1. When x is at 1, y is at -1, 1, -1. We can see our solution on our graph where they intersect at 1, -1. We can also see that on our table. When x is 1, both equations lie at -1. Example B. In order to graph using our calculator, we need to have y alone. So we need to solve for y in each of these equations. The first equation requires me to subtract 4x from both sides. Leaving me with -y is equal to -4x minus 11. I still don't have y alone. I need to get that negative onto the other side. So I'm going to divide by -1 all the way across. And I'm left with y is equal to positive 4x plus 11. Equation number 2, 5x plus 2y is equal to -4. To get y alone, I'm going to subtract 5x from both sides. Leaving me with 2y is equal to -5x minus 4. Then I need to divide by 2 all the way across. Finally giving me y equals -5 halves x minus 2. I can now put both of my equations into y equals. Press y equals, clear out anything that's there, and type your equations into y1 and y2. Remember, we put fractions and parentheses when we enter them in the calculator. Once you have them inputted into the calculator, you're going to press Zoom 6. There's our first equation. And our second equation. We can see an intersection right here. To calculate our intersection, or our solution, we're going to press Second, Calc, that's the trace button. And we are going to select option 5, Intersect. My cursor did not appear on my screen. That doesn't mean that something's wrong. We can see down at the bottom that our cursor is at x is 0 and y is at 11. We know that our window is set to -10, 10. So if y is at 11, our cursor is simply off our screen. Remember, I can use the left and right arrow button to move my cursor anywhere along my line. So if I press the left arrow key, I should see my cursor come across my screen. And there it is. Keep pressing the left arrow key to get it close to the intersection. Remember, it does not have to be exact. Once close to the intersection, press Enter. Check to make sure your cursor is still close to the intersection and press Enter 2 more times. You can see that our intersection is at -2, 3. So our solution is at -2, 3. We need to now get our graph onto our paper from our calculator. To get points to plot, I'm going to go to the table. Second, graph. We can see that when x is at 0 for the first equation, y is at 11, and that's not on my graph. When x is at 1, I can see that y is even further off my graph. Using your arrow keys, you can scroll until you find numbers that are actually on your graph. I don't have the option to change my scale since they have already put numbers in there for me. But I can see when I go to -3, my y is on my graph at -1. -3, -1. I only need one more point on my graph to be able to draw my line. At -2, y is at 3. -2, 3. Now I can draw my line between these 2 points. My second equation, I need to select more points that are on my graph. At -2, y is at 3. -2, 3. At 0, we can see that the line crosses at y is at -2. So 0, -2. Now we draw a line between our 2 dots. As you can see, my solution is where they cross. They cross at -2, 3, and I need to write my solution as a point.